m be a positive integer, if a is congruent to b mod m and c is congruent to d mod m, then a plus c is congruent to b plus d mod m and ac is congruent to bd mod m. This is very important relation, and we should keep this relation in our mind always while we are solving the problems based upon the modular arithmetic. Here we have to go for the proof. We know that a is congruent to b mod m and also c is congruent to d mod m. So this implies that there are integers s and t with b is equal to a plus sm and same d is equal to c plus tm, because the quotient may be different. So here b is equal to a plus sm and d is equal to c plus tm. Here a and c are the remainders and b is the dividend and d is also dividend and m is the divisor. So here we can add b plus d in form of a plus sm plus c plus tm. Also this is equal to a plus c plus m of s plus t. This is simply we are adding the LHS to LHS and RHS to RHS. So here b plus d is the LHS and here m is the common of sm and tm. So m of s plus t here and also c plus a here. So we are simply adding LHS to LHS and RHS to RHS, and the result is BD equals a plus sm into c plus tm is equal to ac plus m times at plus cs plus stm, and hence a plus c, here you can see a plus c is congruent to b plus d mod m and ac is congruent to bd mod m. Here we are going to discuss the Euclidean algorithm. This is also very important for the number theory. The Euclidean algorithm finds the greatest common divisor of two integers a and b. For example, if we want to find the GCD, the greatest common divisor of 287, 91, we divide 287 by 91, and here 287 is equal to 91 into 3 plus 14 in the form of dividend, divisor, quotient and remainder. Here you can see 287 is the dividend, 91 is the divisor, 3 is the quotient and 14 is the remainder. So now we know that for integers a, b and c, if a divides b and a divides c, then a divides b plus c. We have already proved this. And also any divisor of 287 and 91 must also be a divisor of 287 minus of 91 into 3 is equal to 14. Here we are simply shifting the right hand side, 91 into 3 with 287. So here 287 minus 91 into 3 is equal to 14, and same consequently the greatest common divisor of 287 and 91 is equal to greatest common divisor of 14 and 91. In the next step, we divide 91 by 14. 91 equals 14 into 6 plus 7. This means that the greatest common divisor of 14 and 91 is equal to greatest common divisor of 14 and 7. So we divide 14 by 7, and 14 is equal to 7 into 2 plus 0. We find that 7 divides 14, and thus the greatest common divisor of 14 and 7 is equal to 7. So therefore the greatest common divisor of 287 91 is equal to 7. Actually, in the Euclidean algorithm, in the pseudocode, the algorithm can be implemented as follows. Procedure: the greatest common divisor of a and b, the positive integers, like if x is a, y, b, while y is not equal to 0, begin r is equal to x mod y and x equals y equals r. So here the x is GCD of a and b. For the